Explain the fourth and fifth. Right now, I'm going to give you some question.
Okay.
Just wait a minute, please. Or sometimes it doesn't work at all. Now, I'll just adjust my camera. Just wait a minute, please. You are going to solve it and send it to me. Okay? Please do it.
Okay.
I'm giving you half an hour for this conversion. Just wait a minute. Ah, please do it. You'll be able to do this, right? 15th question number.
Yes, sir. I can. Sir,
Yes, Umam.
sir, I'm not getting how I should do it in two steps.
Okay,
Because
I'm
first
just gonna show you the
one and
first one.
third one is not in-
Okay. Try to understand this. So you need to convert propanone into propene. That means propanone, you are going to write the structure propanone. This is your propanone, and which three carbon is there, and you need to convert this into propene. CH3, CH double one, CH2, right? So which
Yes.
reagent you are going to use and how many steps that you are going to use? It's very easy. First, what you are going to do, you are going to reduce this into alcohol. So we can easily, wait a minute, you can, yes, okay. Wait a minute. No, it's good. Just wait a minute, my this pencil is not working. Yeah, I'm gonna give you hints because this is not working right now. I'm gonna work on it. So basically, you can use on the you can use NaBH4, which is a reducing agent on this propanol. So it will be converted into secondary alcohol, right? Yes or no?
Yes, sir.
And then you can use H2SO4, concentrated H2SO4 and heat. H2SO4 is a dehydrating reagent. That means you are going to remove H2O, so alkene will be formed. Is that clear?
Okay, sir.
Okay, now it's working. Just wait a minute. I'm gonna show you the reaction. Very simple it is. You are going to use NaBH4, sodium boron hydride. So this will be reduced to alcohol. This will be directly reduced to alcohol. So H and H here it will be, and it will be CH3, CH, OH, CH3. And then you can use concentrated H2SO4, which is a dehydrating reagent. That means you are going to remove H2O. So OH from this side, hydrogen from this side. So there will be a double bond between these two. Yes, Austin. Start.
Got it.
Please do it. Just wait a minute. I'm not fix your camera properly. I'm not able to. Just I'm just gonna switch off my camera for a while. Just need to work out on my pencil. Okay, please do this conversion.
Okay, sir.
The rest of the question you will be able to solve yes or no. If you are not able to solve any one of this part, so what do you need to do? You just need to escape. Sorry, you just need to escape to the next question. Okay.
Okay.
Let me know if you have any doubt. Come on. Austin, are you able to solve this? Yes or no? Very good. Please do. And please write it clearly and send it to the Learnivio's coordinator. And I needed to ask you something that they told me. Please ask them to attend. Okay, this is what. After class, you attempt you always go for an assessment test, right? Just after class, both of you, Humam.
Yes, sir.
So that is already uploaded, but both of you didn't attempt that. So after this class, you are going to attempt that. Okay.
Okay.
Just wait a minute. Are you able to solve this?
Recording in progress.
Am I audible? Just wait a minute. Everyone done with this? How many questions you have done?
Your voice is not clear.
How many questions have you solved?
I mean, sixth one.
Am I audible?
Yes, sir.
Okay. Do you want me to explain any question in this out of 1 to 9?
Yes, sir.
Question. Which part?
Fourth,
Fourth part.
fifth also. Fourth.
Okay. Okay. So fourth is benzene to M-nitroacetophenone. This is your benzene, and you want to convert this into M-nitro acetophenone. So basically, very simple. This is acetophenone is this. This is your acetophenone and M-nitro. So here it will be NO2, right? So very simple it is. If you want to go in this, what we need to do first, I'm going to react this benzene. If you remember Friedel-Crafts acylation, in which we are going to use this CH3COCl in the presence of anhydride AlCl3. So this is your Friedel-Crafts acylation. Friedel-Crafts acylation, not alkylation. And you can see here it will be eliminated and plus will be there and it will be attacking benzene like this. And there will be formation of COCH3, that means acetophenone. And then you are going to react with nitrous, that means HNO3 in the presence of H2SO4. Due to this, what we have is very simple. Due to this reagent, you will be getting an electrophile NO2 plus. And this you can see is your minus M effect. So only one place that is left where this electrophile will attack, and that is your meta. So this is your CH3, which is having minus M effect. So NO2 will be directly coming to this place. MO2 is directly coming to this place. That means meta. Because due to this minus M effect, there will be positive sign at ortho and para. That means electrophilic center. So NO2 has only one place left without positive charge, that is meta. Is that clear?
Yes.
After this, the fifth one, if you are going to see, you need to convert benzaldehyde. This is your benzaldehyde into benzophenone. Benzophenone means, you can see this is your benzophenone. It's a common name, C double bond O, and there will be pH, that means like benzene. So how you are going to prepare it? It's also very, very easy. What we need to do is we are going to make this CHO. That means you can see this is your CHO aldehyde, and using only HNO3, which is an oxidizing agent. This is your oxidizing agent. You can use KMNO4 as well, alkaline KMNO4. So this will be directly converted into, followed by hydrolysis. So this will be directly converted into, you have seen the preparation of carboxylic acid, this carboxylic acid. After this, you are going to convert this into SOCl2. So this OH will be replaced by chlorine, and you will be getting this COCl. After this, what we are going to do, very simple. We are going to react with benzene. We are going to react with benzene anhydride AlCl3. So benzene is a hydrocarbon. So we can say it is also this is a hydrocarbon. That means and this is acyl halide. So Friedel-Crafts acylation again taking place. This will be converted into positive, and this CO positive will be directly attacking on the benzene anywhere. So benzene is there, and this CO will be attacking. So there will be C double bond O, and this C is connected with this benzene. So you can directly get this. Is that clear? Now, after this, what we are going to do? Just wait a minute. Are you done with this? This is first time I'm using my iPad because this is not the pencil, pen tab pencil is not working. Please do write it. Then we are going to discuss another one. So it says so it should be maximum 2 steps. How will you bring about not more than 2 steps? Okay. I didn't see that. Just wait a minute. So is there any way? Yeah, we can do this in 2 step as well. Can I change the slide? Can I change the slide?
Yes.
Okay, see. In two steps we can do. I didn't see that. So there is benzaldehyde that is given. Just wait a minute. Okay. So there is benzaldehyde that is given. You can see this is your benzaldehyde. So what I'm going to use, I'm going to use Clemenson reduction. If you remember, Clemenson reduction is nothing but zinc amalgam. Okay, this is your zinc amalgam in the presence of just wait a minute. Oh shit. Or we can use Wolff-Kishner reduction. So zinc amalgam we are going to use Clemenson reduction. This whole will be converted into hydrocarbon. That means you will directly get this benzene. And after getting benzene, what I'm going to use, I'm directly going to use this COCl in the presence of anhydride AlCl3. This is another reactant. This is other reactant. So what will happen here? Very simple it is. You can see here it will be removed and there is an electrophile that is prepared and this will be attacking at any position in benzene. So you will be getting C double bond O. Now, is it clear, Humam and Austin?
Yes.
Please go for the next one. Is there any other doubt?
I'm
Can you
doing
do
so.
the, what did you say?
Doing so, 1 minute.
Okay, so take a screenshot. You can do this at home. No, we are going to start the chemical reaction. Will that be okay?
Okay, sir.
Austin, what? How many questions have you solved? Until 7. Okay, there is 3. You can do that. So let's start the chemical properties of this. So chemical reaction. Very simple reaction this is. Chemical reaction. Now see what is this chemical reaction. I'm gonna show you. Very simple it is. First, we are going to talk about acidity. Everyone knows that carboxylic acid is acidic in nature. So acidity when we are going to talk about. So since it is an acid, so when it will react with metal, it will give salt plus hydrogen gas. So this is your carboxylic acid going to react with sodium. I took 2 mole because we need to balance only. So this will be converted into Rc double O negative and then Na is there, Na positive. This is your salt plus hydrogen gas. To balance it, we multiplied it by 2. And this is called sodium carboxylate. Sodium carboxylate. Okay. After this, if you are going to react an acid with base, what will form? Salt plus water. Very simple. So this is also very easy to understand. You know that this is plus, this will give plus, this is negative, this is negative, this is plus. So this positive will directly going to negative. So it becomes Rc double O negative Na positive plus it becomes H2O. So this is very basic reaction. Basically, you know that what is when acid react with base, what will form, when acid react with metal, what will form. And if you are going to react this with sodium hydrogen carbonate, this also you have studied in class 10th as well, that it will give carbon dioxide as well. That means acid is there, sorry, salt is there plus CO2 carbon dioxide plus water. This reaction I think you have studied in class
10th. Yes or no? Is that clear?
Yes.
Okay. Also, basically, when you are going to dissolve or put this carboxylic acids in water, carboxylic acid in water, what will happen? It dissociates. It dissociates in water to give resonance stabilized carboxylate anions. Carboxylate anions and hydronium ions as well. Hydronium ions comes from where? Hydronium ion has a formula. Can anyone tell me, both of you? Hydronium ion is H3O positive. So I will show you the reaction and the what do we say? I will show you the reaction as well as the resonating structure. Please do write it and let me know. Let me know when you're done with this.
Done, sir.
Very good. Moving to the next, where I'm going to show you how it is, how it dissociate into carboxylate anion and stabilizes by resonance. So let's say this is your RC double bond OH. When you are going to react this with water, you know that what will happen. Since this is an acid, so it will give H plus. So there will be negative sign and this becomes H plus. And there is a lone pair. So this will be attacking on this and it becomes RC double bond O negative. Lone pair is also there. Very simple. And plus it becomes H3O positive. This is your hydronium. Now what will happen? Then the resonance start. So this will be like this. Just wait a minute. So I'm going to again write it. It will be like this, RC double bond O negative. So this will be going like this. This will be going like this. So it becomes RCO negative double bond O. So this is your resonating structure. If you want to draw the resonance hybrid, it's very simple. Wherever the pi bond moves, you are going to show it by dotted line like this, dot, 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 or negative charge, because negative charge migrated from top to bottom. Is that clear? Please do write it. Let me know when you are done with this. Both of you done with this?
Done, sir.
Very good. Now see, for acidity, we already covered this. Like if you want to go for acidic character, you know that acidic character, I'm going to write it again. Directly proportional to minus I, directly proportional to minus M, directly proportional to Ka, inversely proportional to plus I, inversely proportional to plus M, inversely proportional to pKa. pKa is, you have studied this, inverse of Ka. So this is a formula of pKa, and also inversely proportional to Kb. Kb is directly proportional to base. So if Kb is more, basic is more, that means acidity is less, and directly proportional to pKb, because pKb, they are interrelated to each other, log Kb. So if you have higher value of Ka, that means more acidic. So more acidic, that means less basic. Are you getting my point? That means less basic. And less basic, that means Kb less. And pKb will be more. Are you getting my point? If you have more Ka value, then more acidic. If something is more acidic, so it is means less basic. Less basic, that means Kb. Kb, or just wait a minute. Let me explain in this term. More acidic, so we can write more acidic, that means pKb will be lower. And if you are going for Kb, Kb is greater, that means more basic. More basic, that means pKb will be lower. Here I should write pK instead of this. Because are you getting my point? This point.
Yes, sir.
And also this is very important. Minus I, electron withdrawing group through sigma bond, electron withdrawing group through pi bond. Okay. So more pi bond, more with electron withdrawing power is there, more acidic it will be. So just write it. Are you done with this? Very good. Hamam,
Yes, sir.
let me know when you are done with this.
We are done, sir.
Okay. Now see. This I'm going to write the order of acidic character, the power. So I'm going to write the effect of the following groups in increasing acidity order is very simple. It is phenyl will have less electron withdrawing power than iodine, then bromine, then chlorine, then fluorine. Fluorine is more electronegative. CN, then comes your NO2, and then at last the most will be CF3. So this order is also very important. Okay, tell me which one is more acidic. This is COOH, which has OCH3 group. Then you have this one, which has COOH group only. ABC, let's say ABC is this. Which one is more acidic? This is your A, this is your B, and this is your C. Very good. AJ, very good. Mom, are you done with this? You need to arrange. See, very easy it is. This OCH3 is plus M effect. There is no plus M plus minus M, there is minus M. So the most acidic is C, then B, then A. This is due to plus M effect, and due to plus M effect, it decreases the acidic character. Here, neither plus M effect nor minus M effect. At least there is nothing in B which is reducing its acidic character. Is that clear?
Yes.
Okay, can I change the slide?
Yes.
Let me know. Okay. Now we are going for the chemical reaction. This is reactions involving cleavage of COH bond. Cleavage of COH bond. So basically, you know that C double bond OH is there. So we are studying the reaction involving in which this bond is going to be cleaved. And in this, we have the first one, formation of anhydride. Formation of anhydride. How the formation of anhydride takes place? Very simple. We need to take 2 moles of carboxylic acid like this. We need to take 2 moles of carboxylic acid like this. And then we are going to use, we need to remove H2O. Just wait a minute, please. We need to remove H2O, this H2O. Oh, we need to remove this H2O. This H2O. Now you can see. And for removal of H2O, either we are going to use H plus, that means H2SO4 or heat, or either you can use P2O5, which is a dehydrating reagent or heat. So what will happen? This will be converted directly. O will be left here, anhydride. And this can be called preparation of anhydride. It has a name that is ethanoic anhydride. And this is your ethanoic acid. So please do write it. Very simple it is. The reaction, chemical reaction of this is very simple. And let me know when you are done with this.
Done.
Okay. Moving to the next, that is your esterification. You have studied this in class 10th as well. Esterification, the same reaction. See, in esterification, very simple things happen. We will study more about esterification in alcohol. Carboxylic acids are esterified with alcohols or phenols in the presence of a mineral acid like H2SO4. You can use mineral acids such as concentrated H2SO4 or HCl gas as a catalyst. So what happens here? Very simple reaction I'm going to write. There is RCOOH, carboxylic acid. It is going to react with R-OH. So there will be RCOOR plus H2. You know what happened here? Very simple. All I want to say is that from here, OH minus simple C, RCOOH is there. And here, OH R dash is there. Just wait a minute. So here again, you are going to remove this H2O. H2 from here, H from here. And you will get what? You will directly get RC double bond O, OR dash, simple ester. And this is called esterification. It has a name. You can alkyl, it is basically alkyl, alkaline, alkanoid. And let me know when you are done with this. Are you done with this? Both of you, are you done with this? Umam?
Yes, sir. Done.
Now we are going to do this. The third reaction of this COH reaction with. This is similar to the alcohol reacting with PCl5, PCl3 and SOCl2. A reaction with PCl5, PCl3 and SOCl2. So see what happens. You already know what happens. OH will be replaced. So very simple it is. If you are going to react this carboxylic with PCl5, this OH will be replaced. This OH will be replaced. And it becomes RCOCl. That means acyl halide along with the same reagent, the byproduct UCl3 plus HCl. And if you are going to react this RCOOH with PCl3, again the same thing will happen. This will be replaced by again Cl, and then again the same reagent will be appearing as 3PO3. And if you are going to react with SOCl2, this OH will be replaced by Cl and the same byproduct basically, if you remember haloalkane. So very easy reaction, right? So this is it for today. In the next class, what we are going to do, we'll complete this reaction. And we are going to start alcohol. A very easy chapter. We can easily do this. And please do attempt that assessment.
Okay.
So let me know when you're done.